yami ngayirestart mara still isawala.
Miskomo.
Yes.
Please, it's okay.
Funa phone kuseni.
I only muting everybody. I've been telling you to mute yourself when you get inside. I really don't understand if you mic is on and then you can't be muting anyone. Okay, please let's start. Today we're starting with chapter 4, nonlinear functions. Okay, if you did that linear functions, then this chapter will be easy for you because we'll be doing everything that we did in linear function. It will be minimum, like finding the revenue, cost, and profits for non-linear functions the way as we did in linear functions. So whatever we did in linear functions, that's what we'll be repeating here in this section. Okay. Now, the theorem of nonlinear function again. Just a second, please, my pen. Okay, again, the theory of this function, which is nonlinear function, is considered to be the knowledge that you have gained in grade 12 or somewhere else. Okay, by the end of this class, you should be able to optimize the quadratic revenue, cost, and profits, and then determine the market equilibrium for demand and supply function, and then determine the break-even point for quadratic functions, like for total revenue and total cost functions. Okay. In economics, sometimes the linear function cannot explain the relationship between the variables. So in such cases, we use nonlinear functions. That doesn't why you need to understand the nonlinear functions. And again, nonlinear functions simply means the graph is not straight. Remember, for linear functions, we're dealing with straight lines, right? So now our graph has curves. So it's a curved line, meaning there's a change in between that your graph is not smooth. So today, not today, let me just say in this chapter, we'll look at different types of nonlinear functions, including quadratic functions, cubic, exponential, logarithm, and hyperbolic functions. Okay, we'll start with quadratic functions. Okay, before we even start with quadratic functions, we need to look at the properties of quadratic functions. So that you'll be able to identify or plot them. But here in this module, I won't be asking you to plot them, but then you still need to know how to plot them. Sorry, I'm trying to get okay, we form of quadratic equation as f at x equals ax squared plus bx plus c, whereby a, b, and c are the constant. Okay. These are constants. Okay, for quadratic functions, we have a minimum and a maximum turning point. Okay, it's a turning point. Okay, if this function has a maximum turning point, that means our a is less than 0. And if this function has a minimum turning point, that means our a is greater than 0, meaning it's non-negative. And if our a is equal to 0, that's no longer a quadratic formula, because that means we'll have f at x equals bx plus c. That's the linear function. So it's no longer non-linear, and it's no longer a quadratic function. Okay. We need to find the roots too. And our roots will be determined using this function x equals minus b plus or minus square root of b squared minus 4ac over 2a. It's either you use this formula to find your roots, or you factorize. But if it's not easy to factorize this function, ax squared minus b plus c equals to 0, if factorization, so you can just simply use this equation to find your roots. Okay, then we have this under the square roots, which is b squared minus 4ac. This is called the discriminant, and it's described the nature of our roots, right? If our discriminant, which is b squared minus 4ac, if this is greater than 0, that means we have two real roots. And if, okay, this is A, and if this discriminant is equal to 0, like b squared minus 4ac is equal to 0, that means we don't have roots. Oh, that means we have one real root. We have one root. And if this discriminant, which is c, b squared minus 4ac is less than 0, that means we have imaginary roots. Okay, I won't give you anything with imaginary roots here, just A and B. Okay, remember I said if A is greater than 0 or less than 0, that means our function have a turning point, right? Okay. To get that turning point, it's either a maximum point or a minimum point. You'll use this formula, x is equal to minus b over 2a. Remember, this is our a and this is our b. Then you substitute them back here, and that's how you'll find your turning point. Okay. After finding the x value, which is maybe q, you'll take it back here, substitute it back here, and find the corresponding f value. Okay. Okay. Remember, the aim of this module is to learn how to maximize the profit. And we know that the profit is P equals total revenue minus the total cost. That's what we've been doing in this module. So this is equivalent to, okay, we said the aim is to maximize the profits, right? Okay, this is equivalent to maximizing the total revenue or minimizing the total cost. Okay, so this is what we'll do. We'll try to maximize it's either the total revenue, total cost, and profits for quadratic functions. Okay. Suppose we are given a demand function as P equals 300 minus 3Q, right? Whereby P is the price per unit of a good and Q is a quantity produced and sold. Right? From this demand, the total price, the total revenue is equal to the price per unit times quantity sold, produced and sold, right? And our quantity here, our demand, okay, our P is given as 300 minus 3Q, and then we multiply with our quantity, right? And if we do that, we will have 300Q minus 3Q squared. Remember, I said the aim here, it's either to maximize the profits, or we maximize the total revenue, or we minimize the total cost, right? Okay. Let me rewrite this equation. We have total revenue equals minus 3Q squared plus 300Q, right? Okay, we have the total revenue, so that means we need to maximize it. Even though, okay, if I just give you this equation, and I say it's either you find the maximum or minimum total revenue, right? The point. But you see, if you compare this equation to a standard quadratic equation, which is f at x equals ax squared plus bx plus c. You see here, this means our a is equal to minus 3, our b is equal to 300, and our c is equal to 0, right? We have this condition. Where did I write it? Okay, here. I said if a is less than 0, that means we'll find the minimum turning point, right? Which is the minimum point. And then, okay, the minimum turning point, meaning it's either way minimizing the cost or the revenue or the profit. But if a is less than 0, it's the maximum. And then if a is greater than 0, then we'll find the minimum turning point, right? And here, if we look at our total revenue, we have a minus 3, which is less than 0, meaning meaning we'll find the maximum turning point, meaning we are trying to maximize the total revenue, right? And I said the equation for finding a turning point is x equals, okay, in this case, it's P, it's Q. It's Q equals minus B over 2A, right? And our B, in this case, it's 300. And our A is minus 3. So this means we have 3 divided by, oh, okay, I think I forgot this negative. This means our turning point is 300 divided by 6, which is 50, right? So this means we have our turning point would be at Q equals 50. Then we need to find the corresponding total revenue where by Q is equal to 50. And our total revenue is 300 Q minus 3Q squared, right? But our Q is 50. So we substitute 50 in our total revenue. And if we do that, we'll have 300 times 50 minus 3 times 50 all squared, right? And if you punch this in your calculator, you should find 7,500. Okay, we said our A is less than 0. This means we have the maximum total revenue, right? So to interpret this, you can say when 50 units are produced and sold, then we have a maximum total revenue of 7,500. Do we have questions for now? Yes, no. Someone's hand is up. Please unmute your mic and talk. Komzile, was that an old hand? Yes, that was an old hand. Can anyone read it, like the question? Yes, no? Okay, guys, this is the time where you have to say something.
I have one question.
Yes.
If you can just share the screen, I wanted to ask something on the last calculations.
Yeah.
Where you say TR, I cannot see. Can you share that? Yeah, yes. Now I can see. Where you say I understand up to TR is equal to 300 Q minus 3Q squared. But there where you say TR in bracket 50 equal to 300 in bracket 50 minus 3 in bracket 50 squared. When I check on the book, I'm not sure if that 300 next to TR should be there, or did you put it there on purpose, or I'm not sure.
What? The what?
The 50 next to TR, the 50 in bracket.
Oh, I was trying to find the corresponding total revenue if Q is equal to 50.
Okay, no, I see. Okay, thanks.
All right. Sicelo? Any more questions?
No, nothing for now, thanks.
Then let's do another example. Suppose we are given a total cost as 1,800 minus 80Q plus Q squared. Okay, but here in this chapter, in this section, we are trying to minimize the profit and the revenue, or we are trying to maximize those two or minimize the cost. And then here, since we are given the total cost, it means we need to minimize it, right? Again, if you don't know which one to minimize or maximize, you'll take your function. Okay, let me write this as an Q squared minus 80Q plus 1,800. You'll take this function and you compare to the standard quadratic equation, which is f at x equals ax squared plus bx plus c, right? We said if a is greater than 0, that means we'll have a minimum turning point, right? Minimum turning point. That means we'll find a minimum. Okay, that means we'll find a minimum point, like we're trying to minimize that function that we're given, right? And we said the formula for finding a turning point is, okay, let me write Cp is equal to minus b over 2a, right? And if you compare this given function, the total function, and the standard quadratic equation, you have a equals 1, b equals minus 80, and then you have c equals 1,800. You substitute this here, you will have minus 80 over 2 times 1. Then you have 80 over 2, which is 40. This is your turning point when you are given this total cost, right? And then the next step is to find the corresponding total cost whereby Q is equal to 40, right? Yeah, trying to find the corresponding value for your turning point, right? That means you have to take this 40 and substitute it back here in your total cost. And if you do that, you will have, okay, our total cost is Q squared minus 80Q plus 1,800, right? And the total cost of 40 would be 40Q minus 80 times 40 plus 1,800, right? And if you plot, if you punch this in your calculator, you should get 200, right? And then you need to interpret this. We said our A. We said our A is greater than 0. That means we'll find the minimum point, right? We are minimizing the total cost. So since we have the minimum total cost at Q is equal to 40. So this means when 40 units are produced, then the company will make a minimum cost of 200. That's how you interpret this. Okay, let's do another one more example where now it's either okay where we are maximizing the profit. Okay, suppose you are given a firm's total revenue and a total cost is total revenue is 107Q minus 2Q squared, and the total cost is 200 plus Q 3Q, and you are asked to find the maximum profit, right? You have the total revenue and the total cost. Okay, I think from chapter 1, you know that the profits is equal to total revenue minus total cost, right? And our total revenue is 107Q minus 2Q squared. And our total cost is 200 plus 3Q, okay? I will first multiply everything, simplify the brackets, right? Multiply everything in the brackets with negative. And if I do that, I will have 107Q minus 2Q squared minus 200 minus 3Q, right? And then the next step is to collect the like terms, drop the like terms. And if I do that, I have just 1Q squared, right? Power of 2. And then I have a term with Q, 2 terms with Q. I will add, if I add them, I will get 104Q, right? And I only have 200 as in the term of Q to the power 0. Okay, this is our profit. And we said we want to find, the question was, we need to find a maximum profit, right? Okay. To find the maximum profit, that means we need to find the turning point of your profit, like the minimum or maximum turning point. And here, if we compare this to our standard quadratic formula, which is ax squared plus bx plus c, you know that we can tell that a is equal to minus 2, b is equal to 104, and c is equal to minus 200. And our a is less than 0. So this means here we'll find the maximum turning point. Meaning we'll find, after finding the maximum turning point, if we take that point and substitute it back to our profits, that means we'll get the maximum profit, right? And to find the turning point, you know that Q is equal to minus B over 2A, right? And our B is 104, our A is minus 2. And if you punch this in your calculator, you should get 26. Right, so we have Q is equal to 26, and then we said the next step is to take that turning point and substitute it back to our profit to find the corresponding profits. And if we do that, we'll have P equal to minus 2 times 26 squared plus 104 times 26 minus 200. And if you punch this in your calculator, you should get 1,152, right? And then you interpret this information, right? So you'll say, when a firm produces and sells 26 units, then they will get a maximum profit of 1,152 rand. Do we have any questions for now? Yes, no? That's exciting.
Oh,
Yes.
can you hear me?
Yes.
Okay. Good evening, Ms. Komo, and also the fellow students on the group. I just want to understand. I have raised my hand, I think, but until this point, so I've been lost. So I'm trying to understand basically, is there any other formula that we will probably be able to use, except that the one that you started with? and also the case is still going to be experiencing the same breaking audio as like last time we met. Just those things. Thank you.
Did I break today?
Yes, today, man.
Did I? Remember last time only few of you experienced that. Some there was no breaking, and then we concluded that the problem was on your side.
I also can't hear you right now. You have puzzled.
Ms. Nkoma, I
Or
could
maybe it's
say-
my network.
No, when I watch the recording back, it's not necessarily breaking, but it's more like the screen freezes, but your voice continues on. So people get a bit lost. It's also recorded in the recording that you saved lost.
Yes.
Ma'am,
All
Ms.
right.
Nkoma?
We only have yes.
Hi, ma'am, can you hear me?
Yes, I can hear you.
Ma'am, can you please repeat from quantity equals to minus 2b and 104? That's where I got lost.
Okay, I will repeat.
Thank you.
From here,
Ma'am.
okay, we said that, okay, from here we are trying to find the turning point, right? And then the formula for finding a turning point is minus b over 2a. And we said our b is 104 and our a is minus 2. And then we substitute these two here. If we substitute these two, this is what we will obtain, right? And then you punch this in your calculator. This is what you get, 26. And then the next step is to take your Q, which is 26, and substitute it back to your profit function, which is minus 2Q squared plus 104Q minus 200, right?
Yes, ma'am.
And then if you do that, this is what you'll obtain, 1,152.
Okay. Okay, thank you.
Okay. Then to solve the thingy of breaking, the UNISA says we should have at least 10 minutes recording per week. Not necessarily a class. I just have to give you 10-minute recording every week, right? And then in this module, I decided to give class. Since last year, I've been giving classes, right? And then my classes were during the day, but I know some of you guys, you are working during the day. So I decided to work extra hours on Monday and Wednesday. So this I'll give the classes after. Either we go back to during the day, I go to work, I stop working from home on Monday and Wednesday, I give classes there, or I do that 10-minute recording that is required by the university.
Ma'am?
Yes.
I heard you say you do classes at the campus. Which campus do you go to?
It's either on the main campus or the Florida campus. There are no classes there. It's just I do classes like at home.
Oh.
In office. There are no contact classes.
Oh, okay.
That's our possible solutions for now.
I think.
Hello, ma'am.
Yes.
I wanted to say, think the time there, it was a good time for us, as you have suggested. Most of us are working, and during the day, some of us are doing
You know,
their
I really can't hear you. I can't hear anything.
If possible, if you can speak on the time, 6 o'clock afternoon, because it's convenient for most of us. Then if you see if you do those 10 minutes, and I think we also have to know how many of us as students are being affected by this wave that is coming on the videos and breaking. Because not all of us are being affected. Thank you.
Thank you. Okay. I'm not sure if anyone heard you, but I think I had only two things that you're working during the day. You need to confirm how many of you are affected by my network. I didn't hear like the rest.
I think she said it's fine if we can continue with the afternoon, with the evening classes, because she has work during the day.
Okay, thank you. Okay, I had you guys were thinking of opening a WhatsApp group. Please discuss there, and then you will tell me what did you guys like decided that we should do it either during the day, classes in the morning, or we continue like this, or I do the recordings, like those few minutes recordings. Yeah, please let's continue. Yes.
Yes, what I'm saying is evening classes are perfect for us most. Only those who are working in the day. So because even the network is busy in the day. So some of us you find good to they can connect. So I think it's perfect in the evenings, ma'am.
All right, thank you. Guys, let's continue. I think I only have two things, and then we are done. The market equilibrium and then the break-even analysis.
Hello.
Yes, hi.
Hello.
I can hear you. Please talk.
I just want to know if I happen to have a question while you are in progress, should I raise hand or just open up my mic and say a question?
If you raise
Kind of
hand, I
like-
will see you. It's better you unmute your mic and then we talk. Then I will stop and listen.
So you're saying it's better that I mute me and then I speak?
Yes.
All right, thank you.
Evening, Miss Nkomo.
Yes, hi.
Sorry to take you back. I need to understand, how do we see that A is greater or less than 0? Hello?
Said or you. Okay, this is the equation that we obtain when we're finding a profit, right? We have minus 2q squared plus 104q minus 200, right? And we know that the
Yes.
standard equation for quadratic formula a quadratic function is ax squared plus bx plus c, right? If you compare these two, okay, you have this to the power squared and you have this squared, right? So this means this
Yes.
a equals to -2, right? And we have a term that goes with q and a term that goes with x. So this means this b equals to 104, right? And we have plus
Yeah.
c and then this 10, the one that doesn't have q or x. And this 10, you can tell that c, from here, we can tell that c is equal to -200, right? We have a equals -2. Minus any number is less than 0. If a number is like negative something, that means it's less than 0, right? If we
Okay.
had a equals 2, that means 2, we know that 2 is greater than 0, right? So we can say a is greater than 0. Since we know that -2 is less than 0, then we say a is less than 0, since a is equal to -2.
Okay. Thank you for that.
Is that fine? Okay. Okay, let's move on to market equilibrium. Again, we now look at demand and supply function and how we can find the market at equilibrium. Okay, remember that at equilibrium, we have the demand of a quantity equals the supply of a function, of a quantity, right? So even here, for nonlinear functions, to get the equilibrium point, we will use that the quantity demanded equals the quantity supply. Okay. If we talk about equilibrium, we always equate these two, the supply function and the demand function, right? Okay. For example, suppose we are given two functions, quadratic functions, okay, which is the nonlinear function as the demand function as q squared minus 10q plus 25q. And we are given the supply function as px is equal to q squared plus 6q plus 9, right? Suppose we are given these two functions and we are asked to find the equilibrium quantity. Okay, we said to find the equilibrium point, we'll use this P, the demand function equals the supply function. Okay, our demand function is q squared minus 10q plus 25, right? Equals to the supply function, which is q squared plus 6q plus 9, right? Then the next step is to simplify this function. Okay. I will take all the terms with q to one side because I'm trying to solve for q, and then the terms without q on the other side. And if I do that, I will have q squared minus 10q. Then I'll transpose these two to this side, then this one to that side. Remember, if you transpose anything to another side of the equal sign, the sign changes. So this means we'll have minus q squared minus 6q equals 9 minus 25, right? The next step is to collect the like terms. We have q minus q. We have q squared minus q squared, meaning the q squares, they will cancel out because it's like we have 1 minus 1, right? And then we have minus 10q minus 6q. If we add these, that means we have minus 16q. And then we have 9 minus 25. 9 minus 25 is minus 16, right? We are trying to find the point, which is Q in this case. So this means we need to divide with minus 16 on both sides, so that we'll be left with Q. If we do that, we'll have Q equals 1, right? So we have Q equals 1. You need to find the corresponding value quantity for price form for Q equals 1. Okay, you can take this Q and substitute in any of the equations. It's either the demand or supply. Since this Q, you obtain that Q by equating these two. So this means if you substitute here, the value that you'll get here, if you substitute that Q, if you substitute that Q here again, you'll get the same value. So it's better you substitute in one equation, right? Since you get the same thing. So we're saving time. So we have P equals Q squared minus 10Q plus 25. This is our demand function, right? Okay, I'll substitute here. If you substitute here, we have Q of 1 equals 1 squared minus 10 times 1 plus 25. If you punch this in your calculator, you should get 16, right? So this means at Q equals 1, both the demand and supply function will give 16. And this is our equilibrium point. Okay, can we move on? Remember, we are repeating
Yes, ma'am.
everything that we did for linear functions. The way we find the equilibrium point in linear function, we'll do the same thing as in here for nonlinear function. Okay, moving on to break even. Again, what we did there for in linear, we'll do it here. Since we discussed the theory of break even under linear function, we'll still use that theory for break even for this nonlinear functions, right? Okay. We know that at break even, the total revenue is equal to the total cost. Okay, we have total revenue equals the total cost, and we know that the total cost is equal to the fixed cost plus the variable cost. So you can even use total revenue equals fixed cost plus variable cost, since this is the total cost, and we know that the total cost here equals the total revenue. Yes. Okay, let's do an example. Break even. Consider total revenue and the total cost. And total revenue, let's think minus 0 to Q squared, and total cost is 8 plus 2Q. Okay, remember we're dealing with a break even, and we know that the break even occurs whereby the total revenue equals the total cost, right? And we know that the total revenue is 13Q minus 0.2 Q squared. And the total cost equals 30 plus 2Q, right? And then we simplify this equation. If we simplify this equation, okay, we will have 13Q minus 0.2 Q squared minus 2Q minus 30 equals 0. Okay, I was transposing these two. this side, and then they change the sign. Okay, I collect the, if I collect the like 10, we'll have minus q squared. We have 13q and minus 2q. This will give us 11q, and we have minus 30 equals 0, right? We are trying to find the points whereby the break, okay, like the break-even point. And we said the break-even occurs whereby the total revenue equals the total cost. Okay, we have the quadratic function. We need to find the points, like the Q, we need to find the values of Q, right? Remember, I said if you want to find the roots, okay, I'll call Q the root here because I want to find the values of Q, and we're given a quadratic equation. And then I said if you want to find the roots and you can't factorize your equation, then you can use this quadratic formula, as in Q equals minus B plus or minus B squared, square root of B squared, minus 4AC over 2A, right? Okay, remember, okay, let me just write this formula. If you have f at x equals ax squared plus bx plus c, right? So you see, we have this equation. It's in a form of this. It's in the same form. So this means this is a quadratic equation, right? So compare these two equations to find A, B, C, and substitute them back here, right? If we compare these two equations, you can see that A is equal to minus 0.2, B is equal to 11, C is equal to minus 30, right? So the next step is just to substitute this ABC back to this quadratic equation. Okay, we said our quadratic equation will be Q equals minus B plus or minus square root of B squared minus A over 2A, right? And our B is 11, yes?
Sorry, man. Just to step. I just want to know maybe a way that you can use maybe to avoid time wasting when you won't be able to find the factors of the above just before you use the quadratic equation formula. So is there a way that you can use so that you can be able to quickly determine that no, you won't get the factors of this? So you should just roll the quadratic equation formula. If there is not, then that will be it. Thank you.
Okay, I can use this. I gave you conditions right before we start. We said if minus B, if B squared minus 4AC is greater than 0, then you know you'll have two roots, right? And then if that is less than 0, you won't have roots since they are imaginary roots, right? And then if it's equal to 0, then you know you will get one root. But as for factorizing, it's like I can't teach you how to factorize. You need to do more exercise for you to be able to determine whether you'll get the factors. But here, you can tell since you even have a decimal number. to save the sign, we can just use the quadratic formula, right? That's saving time. But we've been factorizing since, is it 8? Okay, what is our C? 30. So we have, yeah, this pen doesn't work. We have minus 30. Okay, this is the square root over.
Ma'am,
Okay, my pen doesn't like all of you. Yes,
I just wanted to find out, where did you get the negative 30?
it's, yeah. I'm sure that I've run out of batteries, or this pen doesn't like anymore. Give me a second, I need to change the battery. Oh, okay. It's working. Over minus 2 and our A, okay, minus 2. We said our A is zero comma 2, so it's times minus 0, 2. We have minus 11 plus minus square root of 11 squared minus 4 times minus 0, 2 times minus 30 over minus 2 times minus 0, 2, right? And if you punch this in your calculator, you should get Q equals minus 11 plus or minus square root of 97 over this is this is 0.4 because with 2 times minus 0.4, so it's minus 0.4, right? So we have Q equals plus or minus this. Okay, to get Q1, you'll take plus, and then to get Q2, you use the other sign. So our Q1 would be minus 11 plus square root of 97 over minus 0.4. Then minus 11 minus square root of 97 over minus 0.4. You see, if we said if this in the brackets is equal to 0, that means we'll have one root, right? Because minus 11 plus square root of 0, which is 0, over minus 0.4, you'll get the same number. That's if you subtract 0, because we are adding or subtracting nothing. That's why you get just one value, right? Since this is greater than 0, that means you'll get two roots, which is Q1 and Q2. And if this is less than 0, square root of a negative number is undefined, right? So this means we'll get imaginary values. Yeah, not really. Okay, this is our Q to Q at break even. So the next step is to take this Q. And this is this. I don't know what I did to this pen. Again. Okay, the next step is to take this Q and substitute them back to your and here, and substitute them back here to get the corresponding values when when we have that Q1 is that value and Q2 as that value. So in those two values, it's when you will find a break even. Yeah. Yes, no? Oh, okay, that's right. This is 2.9 and Q2 is 52.1, and then you take these two, substitute them back. Yeah. Oh, you take those two and substitute them back. It's either here or here, since you obtain them by equating the two. And that will be your total revenue at break even, and then your total cost at break even. So that means that's where these two graphs meet. Okay, I've skipped again the plotting of graph, if you see on this section. If you want to skip them too, you can, but if you want to do that, still okay. Yeah. Do we have questions?
Hi, Ms. Ngoma.
Hi.
I just wanted to find out there at the top, where did you get the negative 30?
Negative 30 was we had positive 30, right?
Yes.
Yeah. Right. And then we said we are transposing this positive 30 to this side. If you transpose a number to the other side of the equal sign, it changes its sign. It was positive, and then it will change to negative. You see, we had positive 2q, and then we transpose it to this side. Then on this side, we have minus 2q.
So you transposed everything to the left-hand side of the equal sign.
Yes.
Oh, okay. Thank you very much.
Any more questions? Yes, no?
No, thanks.
Those. Hey guys, if we don't have questions, then stop recording.
Hello, ma'am.